Hello, I'm Sienna Bowes, and welcome to my channel, Learningbuildslife. Today, we are going to talk about the study of an element from the analysis of its electronic configuration, or EC. Today, I am only going to show carbon. Carbon. C. First atomic number. Atomic number is 6. Now, electronic configuration, or EC. EC is 2, 4, Kl, which means there are 2 electrons in the innermost K shell and 4 in the outermost L shell. Therefore, number of valence electrons is number of valence electrons, which means number of electrons in the outermost shell, which in this case is our L shell, is 4. After that, period number. Period number is 2. Since there are 2 shells, period number is 2. Since there are 2 shells, K and L. After that, group number. Group number is 10 plus number of valence electrons, since it is more than 2. 10 plus 4 gives us 14 as the group number for carbon. Next, valency. Valency is number of valence electrons, since it is less than 5. Valency of carbon is 4. Now, carbon's identity. Carbon has 4 valence electrons, so it is a nonmetal since that is more than 3. Carbon is a nonmetal. Finally, the last thing to do. Carbon, with an atomic number of 6, is in between 2 inert gases, which are helium, He, and neon, Ne, with atomic numbers 2 and 10, respectively. Carbon is right in between them, so carbon neither gains nor loses electrons. Instead, it tries to attain the octet configuration of neon. Neon has an electronic configuration of 2,8, which means it has 8 valence electrons. When an atom of an element has 8 valence electrons, which it means it is in an octet configuration. Octet configuration. Neon has an octet configuration. Hence, carbon will try to attain this octet configuration. To do that, carbon shares electrons instead of gaining or losing to form ions, which till now we have been discussing about formation of cations and anions. Instead, carbon shares electrons and forms covalent bonds. Covalent bonds. I am going to represent this with a diagram, but first I'm erasing the board. Now I am going to draw the diagram to represent covalent bond formation in carbon. I have represented carbon with a circle around it, which is the outermost shell, which is the L shell, since the innermost shell is not important here. And here, hydrogen's electrons. Hydrogen has only one electron. Hydrogen's lone electrons is represented with the tiny circle, and carbon's electrons in the valence shell have been represented with cross. Now, I'm trying to explain here that hydrogen has been covalently bonded with carbon. In this covalent bond formation, we can see that by sharing electrons, carbon is able to obtain this 2A of neon, this octet configuration of neon. Carbon is able to attain this octet configuration of neon by sharing electrons, as I say. And if we notice carefully, hydrogen H, which has just one electron, it always tries to attain the configuration of the nearest inert gas to it, that is helium, He. Here it is able to do so again by covalent bond formation. Hydrogen is able to get 2 electrons, which matches the configuration of helium, which it was longing for. Helium, or what hydrogen has attained over here, is called the duplet configuration. Duplet configuration. When an atom of an element has 2 valence electrons, it is said to be in its duplet configuration. And also, carbon, which has a valency of 4, the valencies have also been satisfied for both carbon and hydrogen. Carbon has a valency of 4, which has been satisfied, and also hydrogen has a valency of 1, which also has been satisfied. Actually, the structure is we draw it skeletally. In a skeleton structure, we get this. This is called methane gas. Methane gas, which is a very famous greenhouse gas with the formula of CH4. Now you may take a look at this diagram and understand how carbon shares electrons to form covalent bonds. Hope you enjoyed this episode, and please like, share, and subscribe my channel, and stay tuned for more videos. Thank you.